morning. So I realized that I have kind of a hard sell here because I'm going to talk a lot about Android on an iOS developer conference. So please bear with me. It's still interesting because, well, it's an area of intense interest, right, to do cross-platform development. So I'm Axel. I'm an iOS tech lead for Yelp. Who here has heard of Yelp before? That's more hands than I expected, actually. As I said, I'm working as a tech lead in Hamburg, Germany. We have a dedicated engineering team here. It's the second largest engineering team outside of San Francisco. And the team there is creating the business owner app, which allows business owners to basically modify everything that appears on Yelp about their business. And it also has a number of other functions, like it allows them to communicate with customers. We're responsible for not only the iOS version, of course, but also for the Android app and also for the necessary service backends. So that's basically where my interest comes from when it comes to doing cross-platform development. I just want to thank you to Natasha because she gave a shout out yesterday for Yelp. Yes, we have a beautiful sticker pack, and you should all go download it. We're pretty proud of them. But yeah, we were basically supporting iOS 10 obviously whole, so we're not only having a sticker pack, we're also having a dedicated iMessage app. We're integrated with Maps, so if you're looking for a business in Apple Maps, you will also be able to see the Yelp recommendations and Yelp ratings. I've talked a bunch about Yelp already, but I want to drive home the point why it is so important for us to actually be cross-platform, be available everywhere. Yelp's mission statement is to connect people with great local businesses, and in Q2 we had 92 million unique visitors. And the more important number there is actually 72% of those numbers were coming from mobile devices. That is an important number for us because we started out as a website, like most companies in the early 2000s, but we've seen a tremendous growth in mobile traffic over the last few years. So to do cross-platform and to basically follow up with the needs of your users, your app basically have to be available on all platforms. And what does that mean? That means your customers today are basically looking everywhere and at every point in their life for your businesses and your apps. So you have to be there where they are looking for you. Obviously, the platform that is near and dear to your heart is iOS, and of course, we also started out with the first mobile endeavor that we did was an iOS app. We actually launched as one of the launch partners for the SDK with Apple back in 2008. The second platform that I already talked about a little bit is definitely the web. So you still have to be present on the web because consumers are still using, well, the user studies have shown that consumers are still falling back to the web when it comes to manipulating large bodies of text and being more interactive than customers are still falling back to the web. And also, all of our mobile apps obviously need backend support, need API servers, so this is also why you need the web. And as we heard yesterday from Ben, Swift on the backend on Linux is basically a solved problem. There are a bunch of options for you, how you're able to structure your app, how you're able to build your app on Linux and on the backend. There are multiple options that we've heard. There are a bunch of frameworks. So there's support libraries that allow you to easily generate your API. But there's also, of course, other mobile platforms. And if you look at those numbers, they're from IDC. They're from August 2016. There's something that we as an iOS community tend to forget. Those numbers are mobile devices shipped in overall in worldwide. And the number here that's most interesting is Q2 2016. Nearly 88% of all mobile devices shipped worldwide are Android devices, and only, 12% are iOS devices. So you have to be present on Android. Obviously, there are also other mobile platforms that you might consider, but yeah, of course, I'm just kidding here. Actually, we still have Windows Mobile and BlackBerry apps, so they're not supported by us internally, but if you want to do that. Just to back that up with numbers, the platforms are there, but Windows Phone is considered by IDC with 0.4%. BlackBerry is not even mentioned specifically. It's an others category with 0.3%. So what does it mean that you will basically have to be everywhere and have to be present on all those platforms? It basically means that you're going to implement the same stuff over and over and over. Obviously, there are already ways to share code between various platforms, but they're pretty clunky and they're usually tailored to what the desktop or what the web needs, not so much for what mobile needs. So the actual solution, and that's what we are also seeing within the company, you're basically going to implement everything multiple times. That's why we have an Android team that's basically the same size as the iOS team, just because we need it. But what does it mean if you're going to implement everything twice and then everything, well, multiple times actually? Code duplication always is also bug duplication. I think everybody knows that. Copy and paste inevitably leads to problems, and well, on multiple platforms, you're not even copy-pasting code, but you're actually implementing the same thing on various platforms, so that will inevitably lead to problems. The solution for us, obviously, is we would like to have Swift not only on the back end, on iOS, we would like to have Swift on all those other platforms as well, and specifically on Android. And the great thing is that, well, of course, Apple will never actually support Swift for Android. But the great thing is, as you all know, last year, Apple open sourced Swift. And that allowed basically people to actually start investigating how much effort is it to port Swift for Android and to make it run on Android. And only a few days after the initial announcement, a developer from China, I'm not pronouncing his name, it's probably So Wei, started with a proof of concept. He announced it on the Swift dev mailing list. And what he did, he basically took what's there and did a very, very rough proof of concept that you can actually generate Swift executables on Android. Over the coming month, a bunch of people helped out. Specifically, 2 developers from Facebook were very active there. It is said that Facebook has an internal interest in actually making that happen, because you might have heard rumors that Facebook is looking pretty heavily into Swift as the basis of their ongoing endeavors, and also as the platform of choice when it comes to cross-platform development, basically. So yeah, and I said that well, of course, Apple is never actually going to support it, but they're still open for it. And Chris Ladner was very helpful when it came to solving problems during the development. And well, eventually they merged the Android changes back in the actual Swift master back in April. So you can go ahead, basically take Swift today, check it out, run it, and there is some Android support in there. But what does some Android support actually mean? Let's start by having a look at how Android is actually layered. You all have an idea how iOS is layered and what the iOS technology stack looks like, but most of you probably do not have an idea what the Android stack looks like. So we are starting at the very bottom there. The lowest layer, the red one, as you can see, is the Linux kernel. Sorry. And that already is a pretty good hint on how the port of Swift to Android actually works, because at the very bottom it's just quote unquote Linux, and we already have a pretty good working port for Swift on Linux. So that made made the effort of actually getting Swift to run on Android tremendously easier than if you basically had to implement a whole new backend. Above the very bottom layer, there's a hardware abstraction layer, and then in the middle, the yellow and the purple boxes. Those are basically the meat of Android, so to say. To the left, the purple boxes are a bunch of native libraries, like OpenGL, SQLite, stuff like that you would like to use in your application. but that is originally implemented as a native software on the platform, basically C or C++. And to the right, in the orange box, you see the Android runtime. As probably everybody knows, the Android runtime is a Java derivative. For various reasons, they are not calling it Java. Well, they are not calling it the Java virtual machine. It's Dalvik, and Google has made a lot of changes to the original one with Oracle, part due to a lawsuit, part because they needed it. But that's basically the underlying technology of every Android app. Every Android app is written in Java and runs on top of that on top of that Java runtime and Android runtime. Above that comes basically the interesting part for you as an application developer on Android. They're the Android frameworks. The Android frameworks are basically the equivalent of UIKit and others in iOS. So it's the view system, a bunch of activity handling, lifecycle management, stuff like that. And at the very top, obviously, the actual applications. But what is interesting here is to see that as I said, the actual libraries that you would use to write your applications are above the runtime, and that means they are basically written in Java. Our Swift stuff, obviously, is not there. We're going to write native code, and what we're basically representing the code as in the eventually will be as another native library. So it'll run not on top of the Java runtime, but it will run basically side by side with the runtime. That means that has some implications, basically. You can actually write a full-blown Android app in native code. So there's this thing called the Native Development Kit. We'll see later, because we also need that. That basically allows you to write Android stuff in C, C++, and other native languages. But due to the fact that the actual Androids, that what we would call the Android system, the view system, the lifecycle system, is on top of the runtime, it is really hard to access that from the native libraries. So what you end up usually, there is a class of apps that actually does it. It's games. The reason for that being that games basically do everything on their own. They have their custom UI. They basically don't need everything of what Android actually provides. But for a regular application, of course, you want to have an Android UI, and you want to be a native citizen on the platform, so you will have the need to use those frameworks. So what you are probably in a large number of cases going to end up if you're using Swift on Android, you will basically treat it as treat the Swift part of your Android application as some kind of external library, like you would with other libraries like SQLite or OpenGL, and that has some implications that we will see when we're going through the example later. So now that we've briefly looked at how an Android app is actually structured, what does it mean to run to modify the ecosystem, the Swift ecosystem, to actually be able to produce Android executables? The Swift platform consists of two main parts, and you could also say there's a third part, the support libraries. But the thing that they're most important for us right now is the compiler and is the runtime support. As you might know, the Swift compiler is based on the LLVM compiler platform, and the actual Swift compiler is just quote unquote a front end to LLVM. So if you're taking your Swift sources, they will be transformed into something that's called intermediate representation, IR. And that's kind of you can basically treat it as some kind of bytecode or high-level assembly code. And these LL files, these intermediate representations, then eventually will be transformed into actually assemblies. And the usual path, the happy path for us as iOS developers is what you can see here. You have your Swift source on the left. Then you have the intermediate representation after the Swift compiler is done with it, and then it'll be converted and eventually linked into an ARM64 assembly for iOS. And that is a good thing, actually, because that means that the first two parts of those these steps are already there. We don't need to modify that. The only thing that we actually need to modify is the very last step. We need to generate not an ARM64 assembly for Apple, but instead we need to generate an ARMv7 executable that conforms to the Linux ABI that actually is the basis for Android. So that is the first thing that made the port pretty easy, because you just had to enable that is the assembly generation. And the second thing that made this really easy is that LLVM, actually being an open source software that has been around for quite a while, is already able to generate those assemblies. It already supports Android and the Android platform due to support for Linux. So what was necessary to actually make it happen to that you can compile it? Well, basically the patch, if you're going to the pull request, if you're going to look at it, on the compiler side, it basically just added a bunch of compilation arguments, basically everything that you can here see with the -- Android. That allows basically configuring the LLVM toolchain to actually use that already existing Linux/Android backend, and just take the Swift intermediate representation and generate the Android backend. What you can see here is actually the command line that you would need to compile your sources into an Android assembly. And I've put it here to show something else. Currently, there is not much tooling support. It's pretty early when it comes to Swift on Android. It works, and you can do it, and there are apps on the Play Store that actually support it. But it's pretty crude. There is no real tooling support. It's not embedded in the regular Xcode build chain, nor is it included in the Android Studio environment that they would usually use to generate your Android apps. So you basically have to resort to the command line and do everything by hand. Also worth mentioning is that while you can download binaries for the Swift runtime that run either on macOS or on Linux, you can currently not do that with the Android toolchain. There are no pre-built binaries available. You have to basically download the sources and compile them yourself, which is quite an adventure still with Swift. The second part I mentioned earlier is the Swift runtime. You all know what the Objective-C runtime is, right? It's handling the message parsing, it's handling memory management, stuff like that. And obviously, you also need that for Swift. And Apple's implementation is pretty solid, but of course, being from Apple, it only supports Linux and Mac OS or iOS as native citizens. So we needed to add a bunch of stuff to the runtime to make it happen on Android. The first thing is you need to actually be able to differentiate on what platform you're currently running on. So there is a new directive, OS, parentheses Android, and it works basically like the one that you're already aware of, as you can see in the code example below. You can basically switch depending on what library you're running on. And what you can see in the code example is actually the same that we saw when Ben gave his presentation yesterday. Obviously, there is no Darwin, there's no foundation on Linux or on Android, so you have to fall back to glibc. And that is actually something that also needed to be modified, as we will see later. The second thing that needed to be implemented, there's something called the libicu. As you know, Swift is pretty heavily, well, the Swift string implementation is one of the few string implementations that treats Unicode the way it's supposed to be treated, which leads to a bunch of problems, but it's a very, very pure implementation, and Apple basically did their own implementation in Foundation, but that is not yet available on Android or Linux. So on those two platforms, they fall back to libicu. It's an open source project, originally initiated by IBM, I think in the 90s or something. By now it's handled by the Unicode consortium actually. And usually, when you're compiling stuff when you're compiling Swift for Linux, it usually takes just the libicu that's installed on your native Linux environment. It's usually always there, but you have to basically recompile it on your own for Android. And that means another step where well, there are currently no, as I said before, there are no ready-made binaries, so you have to do it on your own. The third thing is as I already mentioned, glibc instead of Darwin/Foundation is the basis for the actual interface to the operating system. As you've seen in the architecture diagram, the Android platform Android is based on Linux, so it's also based on the GNU libc. But there are slight and very minor differences that the Android port of Swift needs to take care of. So that's why there are a bunch of other things. The third thing, so basically after we've done that, and that was the state that we were in pretty early. That was basically available shortly after Swift was open sourced. But the third step, actually, to get anything useful done is, of course, you need support libraries, right? You need stuff like NSObject, URL request. You need to handle regular expressions, all of that. Most important, libdispatch. And unfortunately, that's not yet available. There are currently two pull requests ongoing for both the port of Foundation to Android and a port of libdispatch to Android. And they're probably, especially the Foundation one, they're probably going to be merged into the actual app repository within the next, let's say, the next 1 or 2 months. But currently, they are not available, and they are also not stable. So that's the main thing that currently makes it hard to actually develop on Android right now in Swift. But yeah, as I said, we'll get there. So now that we've basically settled the what we actually need, what we need from the tooling perspective to make Swift run on Android, let's have a look at how does it actually look from a developer perspective. So what would you see when you're doing that on Android? And of course, Swift enables us to basically solve the problems that nobody was able to solve before. So our example is going to be, well, what's the result of 123 plus 42? Let's start out pretty easily. So as I've said before, you need to play nice with Java, and you're not supposed to basically write a full-blown Swift app, but you need to interface with Java. So let's start with a simple delegate pattern, basically, as a processor delegate. So we'll define 2 protocols in Swift: a listener protocol that supports a method called process number, and then after the processing is done on the Swift side, we need to tell Java about the result. So there's another protocol, responder, that supports a function called process number. 2 things worth mentioning here. The slightly strange naming is just because it's one of the official examples, and the guy who did the example is not a Swift programmer. And the second thing that you might wonder about is the Java protocol thing that the protocol inherits from. That's basically just something in the Java native development kit that allows you to share the protocol both for Swift and for Java, make it accessible from Java. The second thing is let's have a look at the Java side of things. That's, by the way, more or less the only piece of Java that you have to suffer through. For everybody who has already developed on Android, you'll basically immediately recognize this. It's a standard activity. The very first activity that your app jumps into when it's launched is somewhat comparable with your application delegate. And what you see here, that the method onCreate is basically the equivalent of application did finish launching for your application delegate. So that's going to be the entry point for example app. And the interesting thing here is the statement in line 3, native listener bind. That's how you declare a method that is natively written in NDK and thus in Swift, and we will call that later. And as we mentioned before, the Swift assembly is available as a shared library. So what you have to actually do in line 8, you have to load that library into the app, into the memory space of the app. And then you can start calling the native methods. So here we're going to bind our responder. The class implements responder, as you can see. We bind that, and then we have the listener. And then we can call a process number on that method. So let's have a look at the Swift side of things. That's going to be split over a bunch of slides. I'm not going through everything in detail here because most of that stuff is actually boilerplate code, and eventually you will generate that piece of code. There are already a bunch of tools available for other languages than Swift, and I expect them to support Swift pretty soon. But for now, you will have to do all that manually. So you have to start out with a bind method, and what you see here, basically all those arguments and the unsafe mutable pointer stuff, J object, J and I detach current thread. All of those things are the as I said before, the boilerplate code that you need to do to interface Java from a native application. And that's why I said before, currently it's pretty tedious. Currently you're not really set up to do that because you have to support all that stuff. You have to write a large bunch of boilerplate code to support all that. So for example, the actual calling later, you have to create a proxy. Then this proxy, you have to make that proxy aware of your native methods. And then finally, you can actually register those those methods, and then you can have the NDK call them for you. And eventually, you'll hopefully end up with the result that those addition is 165. Why do I show you this? It's basically the question, obviously, that is the main topic of this talk. Should you use this right now? And the answer, unfortunately, is no. It is there. If you're really adventurous, you can use it. We are looking into it, and our Android people are pretty interested in it. But it's currently not ready. And that's basically the main point. So, well, it's not yet ready. We're really going to be there, and I fully expect, if I'm going to do this talk again on the next Pragma conference in 2017, you will actually see work code examples, and there will already be a bunch of apps out in the Play Store that use this. But for now, it's just not quite there yet. While the infrastructure is there, the tooling is not up to par yet. The support in the IDEs is not there yet. And the stuff that you as an application developer have to write is not fully there yet. You have to do a lot of stuff manually. We've talked a little bit about how you actually, but basically we've talked what is available to a native library and what's not. So what are the scenarios that I will actually see Swift being used within an Android app? The main scenarios are basically the lower level cases. So you will definitely be able to share your models, your data layer. You will basically to share your network layer, the business logic. All those are things that you will be able to easily share. What you probably will never be sharing with your iOS app is everything above that. So the UI layer will never be fully compatible with between the platforms. And also, if you're interfacing specific things, you will always have to write either to wrap them up in another layer or just resort to whatever is native on the platform, and that's what I would do. We're talking about cross-platforms, so I briefly wanted to mention a few other options that you can use if you really have to. Sencha and PhoneGap are two libraries that basically are glorified UI web views if you want to do that. Xamarin, we're going to hear a talk later today about Xamarin. That's another option, basically write everything in C#. React Native is an interesting option that became somewhat famous because Artsy, where's Ash? There he is. Because Artsy recently decided to, well, basically JavaScript is the way to go in the future, and I'm really curious. He's not sure. And one honorable mention that I also wanted to point out there, if you have to write Java stuff, and the Android developers probably know that, there's Kotlin. Kotlin is a language that basically looks like Swift. If I had more time, I would show you some examples. But if you're a Swift programmer, you will basically immediately feel home with Kotlin. So that's another option, and it'll probably, so the path of the two languages are somewhat similar. So you will probably be able to share code that you're writing in Kotlin today, transform that to Swift later. And that basically wraps up my talk. We've talked about the side of things. We've talked about the state of Swift on Android today. We're not there yet, but I'm pretty confident. I'm looking forward to start porting iOS stuff over to Android. Thank you.